Space missions away from the Earth. Our lives have become more and more enriched with the help of artificial satellites. We have learned that telescopes aboard artificial satellites are used to gather information about the universe. Similarly, some space missions are used to gain further knowledge about the universe. In these missions, spacecrafts are sent to the objects in the solar system nearby Earth to observe them more closely. New information has been obtained from such missions, and it is helping us to understand the creation and evolution of our solar system. For such missions, the spacecrafts must escape the Earth's gravitational force to travel into the outer space. To achieve this, the initial velocity of the moving object must be greater than the escape velocity of the Earth. Escape velocity on a planet can be obtained using the formula V escape is equal to square root of 2 into capital G into capital M upon capital R. Here, capital G is the gravitational constant and its value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Capital M is mass of the planet, that is Earth, which is equal to 6 into 10 raised to 24 kilograms. Capital R is the radius of the planet, that is Earth, which is equal to 6.4 into 10 raised to 6 meters. Therefore, V escape is equal to square root of 2 into 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 divided by 6.4 into 10 raised to 6, which is equal to 11.18 into 10 raised to 3 meters per second. Therefore, V escape is equal to 11.18 kilometers per second. Thus, if a spacecraft is to escape the Earth's gravitational force to travel to the outer space, it must have minimum velocity of 11.2 kilometers per second. Do you know? The astronomical object closest to us is the Moon. Light takes 1 second to reach from Moon to the Earth. It means that if we travel with the speed of light, it will take 1 second to reach the Moon. However, since a spacecraft travels at a much slower speed, it takes longer time to reach the Moon. The shortest time taken by a spacecraft to reach the Moon so far is 8 hours and 36 minutes. Come then, let us study about the space missions on the Moon in the next part of the chapter. Moon missions. Man had always been curious about the Moon. We can observe the Moon even with our naked eyes. Since the Moon is the closest astronomical object to us, the first space missions to objects in the solar system were the missions to the Moon. Such missions have so far been executed by USA, Soviet Union, European countries, China, Japan, and India. The spacecrafts in the Luna series sent by Soviet Union reached near the Moon. Luna 2, launched in 1959, was the first such craft. After that, till 1975, 15 spacecrafts made chemical analysis of the Moon and also measured its gravity, density, and radiations. The last 4 crafts even landed on the Moon and brought the samples of stones on the Moon for analysis in laboratories. All these missions were unmanned. America also executed Moon missions from 1962 to 1972. The speciality of these missions was that some of these were manned missions. In July 1969, Neil Armstrong became the first human to step on the moon. In 2008, Indian Space Research Organization, that is ISRO, successfully launched Chandrayaan-1 and placed it into an orbit around the moon. It sent useful information to the Earth for about a year. The most important discovery made during the mission was the presence of water on the surface of the moon. India was the first country to discover this. Come, let us study about the missions on the planet nearest to the Earth. Mars missions. Other than the moon, the astronomical object nearest to the Earth is Mars. Many nations send spacecrafts to Mars. Mars mission is difficult and almost half the missions to Mars were unsuccessful. However, ISRO's performance in this mission is remarkable and we all should appreciate it and must be proud of it. The spacecraft Mangalyaan made by ISRO using minimum expenses was launched in November 2013 and was placed into orbit around Mars in September 2014. The Mangalyaan obtained very useful information about the surface of the Mars and the atmosphere around it. After knowing about the Moon and the Mars missions, let us now know about some astronauts of Indian origin who have travelled into space. Let us first know about Rakesh Sharma. Rakesh Sharma was the first Indian to travel to space. He went into space along with 2 Russian astronauts under the joint Indo-USSR space program. He stayed in space for 8 days. You must have surely heard the name of Kalpana Chawla. Kalpana Chawla obtained her engineering degree in aeronautics from Punjab and in 1988 obtained her doctorate from the University of Colorado. She was in space for 336 hours during the research mission. While returning to Earth from space on 1st February 2003, the Columbia spacecraft exploded and Kalpana perished. There is one more Indian astronaut named Sunita Williams who has made us proud. Sunita Williams travelled in Space Shuttle Discovery in 2006 to the International Space Station. She worked for 29 hours outside the space station. She created a record by staying for 192 days in space. Now that we have learnt about some astronauts as well as the Moon and the Mars missions in the earlier part, let us now study about the missions to other planets. Other planets. Apart from the missions to Moon and Mars, many missions have been executed to study other planets too. In some of these missions, the spacecrafts orbited the planets, some landed on the planets, and some just passed near the planet and observed them. Additionally, spacecrafts have been sent to observe asteroids and comets. These spacecrafts have successfully collected some dust and stones from the asteroids and brought them back on the Earth. We are getting very useful information from all these missions which have proved useful in clarifying our concepts about the origin and evolution of the solar system. Come, let us now study how India has made progress in the space technology. India and space technology. India has launched many satellites into space and also has made remarkable progress in the science and technology of launch vehicles. Various types of launch vehicles have been developed to put satellites having a weight of up to 2,500 kilograms into all types of orbits. PSLV and GSLV are 2 such important launchers. The scientific and technological feats achieved by India in this field have significantly contributed to the national and social development. The INSAT and GSAT satellite series is actively working in the field of telecommunication, television broadcasting, and meteorological services. Availability of television, telephone, and internet services all over the nation has become possible due to these satellites only. EduSat satellite in this series is used specially in the field of education. IRS satellite series is working for monitoring and management of natural resources and disaster management. The IRNSS satellite series has been established to exactly locate the position of any place on the Earth's surface in terms of its precise latitude and longitude. Come, let us now know about a great scientist who has done an immense work in the Indian space technology. Introduction to scientists. Vikram Sarabhai is considered as the father of Indian space program. His efforts led to the foundation of the Physical Research Laboratory, that is PRL, at Ahmedabad. In 1962, Indian government contributed Indian National Committee for Space Research under his chairmanship, and the first satellite launch center was established at Thumba in 1963. The launching of India's first satellite Aryabhatta into the space was the result of his efforts. He played an important role in the establishment of Indian Space Research Organization, that is ISRO. Till now, we have studied that numerous satellites have been launched into space. But do all these satellites remain functional forever? The satellites may become non-functional due to some reason. What happens when the satellite becomes non-functional? Also, there are chances of the launcher getting detached during launching of the satellite. What happens in such cases? Come, let us know about this in the next part. Debris and its management. We know that artificial satellites revolve around the Earth. In addition to artificial satellites, some other objects are also revolving around the Earth. It includes non-functional satellites, parts of the launcher detached during launching, and debris generated due to collisions of satellites with other satellites or any other object in space. According to one estimation made in 2016, there are about 2 crore pieces which are more than 1 centimeter in length revolving around the Earth. All this is nothing but the debris in space. This debris can be harmful to artificial satellites. It can collide with these satellites or spacecrafts and damage them. This debris is increasing day by day. Soon it will become difficult to launch new spacecrafts. It is therefore very essential to manage the debris. Some studies and experiments are being done with this in view. Hope that soon we will have a solution to this problem and the future satellites and spacecrafts will not be in danger anymore. In the later half of the 20th century, substantial developments in technology, especially space technology, happened. This resulted in the development of spacecrafts, making space voyage possible. Since then, more than 1,000 artificial satellites have been placed into orbits around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. We shall learn about various space missions in this chapter. The space missions can be classified into 2 categories. In one type of mission, the objective is to put artificial satellites in orbits around the Earth for research and various other useful applications. The objective of the second type of mission is to send the spacecraft to outer space for close observations and understanding of the objects in solar system or even outside the solar system. Do you know? The first person to go into space in a spacecraft was Yuri Gagarin of the then USSR. He orbited the Earth in 1961. The first person to step on the moon in 1969 was Neil Armstrong of USA. Rakesh Sharma of India orbited the Earth in 1984 in a Russian spacecraft. Kalpana Chawla and Sunita Williams of Indian origin also participated in space explorations through missions organized by NASA, that is, National Aeronautics and Space Administration of USA. In the previous grade, we have already studied about the various types of telescopes orbiting around the Earth. Can you recall them? Yeah, right! Some of the important telescopes which are active in space include optical telescope, gamma-ray telescope, X-ray telescope, telescope receiving ultraviolet rays, infrared telescope, microwave telescope, radio wave telescope, and the telescope receiving the gravitational waves. Come, let us now answer a few more questions. We all make use of cell phones nowadays. It has made our lives simpler. We can easily contact a person staying at a distance. But have you ever wondered, where does the signal in your cell phone come from? Where from does it come to the mobile towers? We all love to watch TV. We are even able to see the live telecast of the matches being played in other countries. How does this become possible? Where does the signal to the TV come from? While reading the news, you might have seen photographs showing the position of monsoon clouds over the country in the newspaper. How are these images obtained? All these become possible with the help of satellites. As we have already learned that, along with the natural satellite, there are many artificial satellites orbiting around the Earth. An artificial satellite is launched into space for a special purpose through space missions. Come then, let us now study the need and importance of space missions in the coming part of this chapter.